we can add, subtract, multiply, and divide functions just like we can add, subtract, multiply, and divide numbers. So here are two functions that we're given to be f of x and g of x. And this page is asking us to do two things. One, let's add those functions together. That's all this notation means. Take the f function, add it to the g function. It's a weird looking notation, but that's all it means. So I'm going to take the first function, I'll use parentheses around it, although I may or may not need them in this case. So I've got 3x plus 4 as my f function. I want to add that to the g function, which is 2x minus 3. And from here, all it is a matter of adding up like terms. So I've got 3x plus 2x to get 5x, and then 4 plus negative 3 to get positive 1. So we end up with a brand new function. That's going to represent the sum of the two functions. I'm going to subtract the same way. Again, it's a weird looking notation, but it just means do the f function minus the g function. So again, parentheses, although I may or may not need them. This time you see we absolutely will need them for the second part of this, the g function. I want to subtract 2x minus 3. And so I can drop them off the, or actually let's do it this way. I want to make sure that I sort of distribute my negative when I subtract this. So that's why I needed those parentheses. So I've got 3x minus 2x, which is just 1x. And then I've got 4 minus negative 3, which works out to be plus 7. So watch out for that. So there's my new function that represents the difference of those two functions. To find your domain, just check the domains of the original and check the domain of your answer to see what your final domain is going to be. Well, my original two functions, the domain is unrestricted. It's all reals because it's just a line. If you notice the final two answers, they're also just linear equations. So this time my domain for everything is just all reals. I'll use those brackets around it to show set notation. Or I guess I could do interval notation. For all reals, it would be from negative infinity to positive infinity. So both of these have the same domain. Finally, I can evaluate. I can substitute a number in for x. This is what they're asking me to replace x with. So that's my x. They're saying to do the subtraction function. So here's all I need to do. Since I've already found what the difference function is, all I need to do is take this negative 1 and replace it with x in that function I already found. So negative 1 plus 7 is of course just 6. Real quick, we can also multiply and divide with this. So here's my notation, which is telling me to do multiplication. That's what the dot means, of course. So take the f function and multiply it by the g function. The notation is weird, but that's all it means. So I've got 3x plus 4. And I want to multiply that by 2x minus 3. So you can do FOIL, you can do the box method if you remember how to do that, or you can do it in your head if you want to do this multiplication, but that's all I need to do. So I'll kind of do this in my head, multiplying the first terms, I get 6x squared. Multiplying the outside terms, I get negative 9x, so positive 8x, and then a negative 12. And again, if you like the box method, you can pause the video and try the box method and just confirm that that's what we get. Once we combine like terms, my new function for multiplication is 6x squared minus x minus 12. Alright, which is still going to have a domain that's all real, so I guess let's just do that real quick. Oops, that's a really bad bracket, but oh well. So my domain is all reals. The original had an unrestricted domain, the new one's just quadratic, it has a domain that's whatever. Last up, let's divide. So I want to do the f function divided by the g function. So this time the f function, I'll put it on top, so 3x plus 4 is my numerator. My denominator is 2x minus 3, and what's nice about these is a lot of times there's nothing else you can do, at least not without reviewing some factoring and all that, which I'm sure we'll do later this year. But for now, that's my division function. I cannot simplify that in any way. I've got to be really careful about my domain this time, though, because even though the original functions had an unrestricted domain, this time, since I'm doing a division problem, I have to be careful that I don't divide by 0. So if you recall from the domain video, if you watch that one, I want to make sure that the bottom of this is not equal to 0. So if I solve this equation, or not equation, I end up with x cannot be equal to 3/2. That's the only number I don't want to plug in. And so if I write my domain using set notation, I'll use that bracket and say x such that, remember that's just part of our notation, x does not equal 3/2. Everything else is fine, but don't you dare plug 3/2 into this. Alright, and then once again they can ask us to evaluate. All they're saying is take the number they give you, and that's just the x value they want you to use. This time they're asking us to evaluate the division function, so here's my division function. Let's make both x's equal to 0, which actually makes that really easy to do in my head, since 3 times 0 is 0. the numerator is going to work out to be just 4, and the denominator is going to work out to be just -3. So when I evaluate this, when x is 0, I end up with an answer of -4/3.